Hello everybody, welcome to Act NEET Physics by Arun video channel. In today's video, we are going to solve an MCQ, of course lengthy one, in the chapter Current Electricity. What is the question, sir? Let us look into the question. Question is so small, but the answer is somewhat lengthy. Okay, that's all. The equivalent resistance of the infinite network given below is how much? This question has been asked in the NEET examination in the year 2022. See, this is the infinite network consists of a number of 1 ohm resistors. 1, 2, 3. Once again 1, 2, 3. Once again 1, 2, 3. Once again 1, 2. Of course, there is a 3 there. Okay, that's all. So, even before this first section, you have a number of such sections in the LHS. Even after this last section, there is a number of sections like this beyond this also. Okay. So, how to find the equivalent resistance of this network? For that, you have to redraw the figure like this. So, this is the. So, I have given you a red box. So the total resistance up to this box, it means what? All the resistance which are beyond this. How many sections are? It is infinite. Okay, that's all. Is X. And also we assume that the resistance across A and B, actually that is also X. The value of X between A and B is we are going to find out. Okay. So as the network is infinite, it is right, it is justified to assume that the equivalent resistance X of all resistance inside the red box is equal to the resistance across A and B. In the resistance X தான் இது மொத்தத்துக்கும் சேர்ந்து X தான் அப்படிங்கிறது ரைட் தான். ஏன்னா இந்த மாதிரி இந்த பாக்ஸை இங்க போடுறதுக்கு பதிலா இன்னொரு செக்ஷன் சேர்த்து போட்டுருந்தோம்னு வச்சுக்கோங்க, நம்ம அதை எக்ஸ்ன்னு சொல்லுவோம், அதுக்கு அந்த பக்கம் உள்ள இதையும் நம்ம எக்ஸ்ன்னு தான் சொல்லுவோம். அதனால எத்தனை செக்ஷன் சேர்த்தாலும் ஏன் இப்படி சார் அது? பிகாஸ் இட் இஸ் திஸ் நெட்வொர்க் இஸ் இன்ஃபைனைட். ஓகே, so it is justified to assume that this is also X and that is also X. Okay, now let us find the value of X. So now you can find, we assume that resistance up to inside this box is X. Now in the network we have 4 resistances. What are these 4 resistances? This is 1 ohm, number 1. This is 1 ohm, number 2. And this is 1 ohm, number 3. And parallel to this 1 ohm we have X. Okay, understand? Parallel to this 1 ohm we have X. Okay, that's all. So you have redrawn the figure. 1 ohm, another 1 ohm, this 1 ohm, parallel to this you have X. So what is the value equivalent resistance for this arrangement? So let us find. The equivalent resistance X is given by the figure. Here we have 3 1 ohm resistances, 1, 2, 3, and an equivalent resistance X for the inside the red box in the previous slide for the remaining resistances in our lectures. So now let us find the equivalence for the parallel combination of 1 ohm and X. What is the formula for parallel combination? 1 by xp is equal to 1 by rp is equal to 1 by r1 plus 1 by r2 3. So here 1 by xp is equal to 1 by 1 by 1 plus 1 by x. Okay. So now you can take x as the LCM. So here you have 1, here you have. So x plus 1 by x is the answer. You can write whether it is 1 plus x or x plus 1, both are 1 and the same. So 1 plus x by x is equal to 1 by x. Then what is xp? You just inverse it. X divided by 1 plus x. So now we have found the equivalent resistance of these 2 resistors. Now we have, so far we have 4 resistors, 1, 2, 3, 4. Now we have only 3 resistors. What are these 3 resistors? This 1 ohm, number 1. This 1 ohm, number 2. And x by 1 plus x, this value of xp. This is the third resistance. Now, these 3 resistors are just connected in series only. Okay? So these 2 resistances are parallel, but you have found the equivalent value, that is x by 1 plus x. Now we have only 3 resistance, one x by 1 plus x and another one connected in series. So how will you find the value of resistances connected in series? Xs is equal to Rs is equal to R1 plus R2 plus R3. So like that only. Xs is equal to x. So it is x only that we have put in the earlier slide, is it not? This is also x, this is also x. X is equal to 3 resistance, 1 ohm, plus x by 1 plus x by 1 plus x and 1 ohm. Because in series connection you have to add all the resistors. So now this is 1 by 1, this is x by 1 plus x, this is 1 by 1. So you can take the LCM. What is the LCM? This is denominator, 1 plus x. Then how to simplify this? How to solve this? 1 plus x. So in the 1 plus x, the common எடுக்கும்போது 1 into 1 plus x. அப்புறம் இங்க வெறும் x மட்டும் தான். ஏற்கனவே 1 plus x இருக்கு. அடிபட்டு. Plus 1 plus x. So 1 plus x plus x plus 1 plus x whole divided by 1 plus x. What you are doing now, sir? You are finding the value of series connection of resistance. X, yes, this is also equal to x. Okay, let us continue the work. X is equal to இது அப்படியே தான் எழுதிருக்கோம். அப்ப என்ன சார் இருக்கு? X is equal to 1 plus x plus x plus 1 plus x whole divided by 1 plus x. It is equal to what? 1 plus 1, 2. X, இன்னொரு x, 3x. So 3x by 2 divided by 1 plus x. You put this 1 plus x to the other side. X into 1 plus x. What is remaining here? 3x plus 2. Okay? So x into 1 plus x is equal to, that's all. This is nothing but your algebraic equation. An equation in algebra. So x into 1 plus x is equal to 3x plus 2. So x into 1, x. X into x, x square. That is equal to 3x plus 2. Now you put all the things to the LHS. You put x square, முன்னாடியே போட்டுக்கலாம் x square. This 3x, when it goes to the other side, becomes minus 3x. So minus 3x plus x, that is equal to minus 2x. This 2, when it goes to the other side, becomes minus 2. So now you have an equation. From this term, you are arriving this equation. X square minus 2x minus 2 is equal to 0. What is this? Yeah. This is a quadratic equation. படிச்சிருக்கோம் algebra. We have seen this in algebra. This is quadratic equation. What is the solution for a quadratic equation? படிச்சிருக்கோம். X is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. Is it not? This is the form of solution for the quadratic equation. X is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. So you compare a square plus bx, ax square plus bx plus c is equal to 0 to this equation x square. What is the value of a? Is equal to 1. Yeah, it's mere x square. So a is equal to 1. X square plus 2ab. So 2b is equal to minus 2. Ax square plus bx plus c. Yeah. So a is equal to 1, b is equal to minus 2, and c is also equal to minus 2. Ax square plus bx plus c is the standard quadratic equation, and its solution will be in the form of this. Is it not? So now we can substitute the value here in this equation. So x is equal to minus b, minus or minus plus 2 plus 2, plus or minus square root of b square minus 2 into minus 2 plus 4. So b square minus 4ac, 4. What is a? 1. What is C? Minus 2. So 4 into minus 2, minus A. Divided by 2A. What is 2? What is A? 1. Okay. So x is equal to plus 2 plus or minus square root of 4 minus of minus 8. Of course, it is plus 8. So divided by 2. So it is x is equal to 2 plus 2 or 2. You can write anything. So 2 plus or minus square root of 4 minus or minus plus 8 divided by 2. This 2 is common for all the terms, is it not? So 2 plus or minus 8 plus 4 what? 12. 12 the whole divided. So 2 plus or minus square root of this 12 can be written as 4 into 3. Almost 12, 4 into 3, 12, is it not? Okay. Divided by 2. That is x is equal to 2 plus or minus this 4. If you take this 4 outside the square root, it becomes 2. So only this 3 is inside the root, is it not? Plus 2 into divided by 2. The 2 inge 2 adicha 1. The 2 inge 2 adicha 1. So 1 plus or minus, of course, plus or minus root 3. So here you can, by all means, negative sign can be ignored. You can ignore the negative sign. You can consider only the positive values. X is equal to 1 plus square root of root 3 ohm. This is the answer for this question. You can solve similar questions in the case of 2 ohms, 3 ohms, in the case of infinite network also. You have to arrive at a quadratic equation and solve the problem. Okay. Anyway, this is somewhat lengthy. I think it is somewhat difficult to answer such a questions in a single minute. After all, you are allotted only 1 minute for a question. You have to manage. Okay, that's all. So we will see one more question in this chapter in the next video. Till then, thank you one and all.